Hello, everyone, and welcome to an Emacs chat. I'm talking to Wasamasa, who had a fascinating 5-minute demo of graphics in Emacs at yesterday's Emacs Conf. So we figured we'd follow up with a full-length chat, into demonstration, presentation thing. Here he is. Actually, Wasamasa, can you switch back to your video first so people can get a sense of who you are and what you're like?
No, the thing is I don't actually have a webcam or anything.
Okay,
Nothing
that's
built
cool.
in, no external
All
one.
right.
So
That's
yeah.
totally all right. Okay, so let's jump into it. Well, actually, before we go into the demonstration, tell me a little bit about how you got started with Emacs and what got you into it.
Well, actually I was studying computer science and had to do an internship at a place. And one of my tasks there was to revamp manual about setting up a server. And my predecessor, he had a note in it that one should use something like Vim or Emacs as the editor, but forgot to add a tutorial. So that was one of the first things I've added, and I've decided to just try out Emacs and Vim. I started off with Vim first because it seemed a lot simpler, and I actually kept using it for about 6 months, something like that. But I found a few things I wasn't really fine with, like its syntax highlighting for LaTeX was very, very slow, and that wasn't acceptable because I did my manual in LaTeX, and so I need something better than this, and it wasn't really customizable, and I'm really, really picky about this. So I decided to just try out Emacs because I've heard it had this great Vim emulation thing called Evil, and it just hit 1.0, so I thought it must be good, and it actually was. It actually was. It took me quite a bit to get used to it because it's very different. It's the same story in Vim. I am a slow learner, and it took me about 2 weeks to just get used to it and have something like notepad efficiency in it. So yeah, with Emacs it took me 2 weeks to learn how to do basic navigation. Then I used Evil, and from then on I progressed slowly.
Wow.
So yeah, I've been using it for about a year before I started actually learning Emacs Lisp. And a year later, I did my first talk at FrostCon, where I just did, in this talk, I did demonstrate why you should learn Emacs Lisp, and did demonstrate some of the things I'm going to show here. And this year, this would be my 3rd year of Emacs, I have demonstrated more graphical things only, and a bit more what you should know before you want to do the next Mario or some shooter or anything in it.
That's excellent.
So, yeah.
There you go. I'm glad you found an editor that accommodates your pickiness. Emacs is very, very good for that. And it's great that you picked up so much in just a year of learning things. After a year you went to Emacs Lisp, and now after a couple of years now you're doing all sorts of fascinating things. So
yeah,
computer science, like what else are you interested outside of Emacs?
Well, other than this, I'm of course all the natural sciences. Like I'm very interested in physics, chemistry, and all that stuff. And outside it, I like doing photography. And recently, one of my coworkers, told me we should totally hit up the gym. So I'm doing weightlifting there. And yeah, there's a lot of interesting things out there. So I'm always interested in if someone has something interesting to go at and pursue that if it's cool enough for me.
Are you using Emacs to help with any of those other interests?
Well, not really. I had first the idea that I should totally use org mode to organize my life, but it's just too big to be really mastered. So I'm only using it for very basic things like my talks and a calendar, because there's this really cool package KLFV, which displays an ASCII calendar of all your org stuff. And yeah,
I have to
other
check
than that,
that
I use
out.
it for project documentation.
Oh, then maybe if you don't have sensitive information on your calendar at the moment, then you can include that in one of your demonstrations
no,
later.
it's just my current schedule for university.
Awesome. Okay, by the way, we already have a viewer watching this stream. So if you have any questions, or if you're watching this afterwards as well, feel free to submit them through the built-in Q&A app or by commenting on the event page, and I'll pass them on to Wasamasa. So that's the calendar that you're talking about with 9:45 and other things like that. That is really cool. Okay, so
it doesn't play well with that font size though.
Well, that's okay. I'm sure it looks really nice in a larger larger resolution, smaller font size. Okay, so one of the things that I really want to follow up on is that graphics demo that you did yesterday with Tetris and the Game of Life and whatever. You mentioned this was a 45-minute talk originally, so let's go over for something in between the 5-minute demo that you did, which was a very great overview, and something like a little bit more fleshed out. What are the sorts of things that you wish you had time to share yesterday?
I would have liked to share how this all actually works, because this was very quick, even at the original talk. I had the impression that I've just left people speechless pretty much, because I didn't get any questions or anything, just applause at the end. And yeah, so I would have really liked to explain why buffers can do this kind of thing, why it's actually fast enough, and what the mechanics are behind all of this.
Oh, and, for sure.
Yes, because this doesn't really seem like actually researched area, if we can speak of research with Emacs, of course. So yeah, I've started a blog recently, and I guess I would use it to write about that kind of stuff there,
for
if I don't have anything important.
Oh, I think that's important enough to share for sure. How does it work? I mean, a lot of people think of Emacs as a text editor, and I know it can display, graphics. It can even display animations. But how does the code actually work to do all these things?
Well, it all starts with buffers, because in Emacs, strings aren't the first class data type like in other languages. You instead work on the buffer instead. And buffers have many interesting properties. You can, for example, think of them as a string, of course. They are basically a string at the beginning, a string at the end, and a gap between, which have given them the name gap buffer. And yeah, there are properties attached to them. For example, if you open a C file in Emacs, you are very likely going to see a syntax highlighted buffer. And this is because there is a mode that attaches to the parts of the text in it various properties, which are commonly called text properties. And one of these is the face property, which tells it to use a certain syntax highlighting information. And that allows this effect. There are, of course, a few more. Most of them aren't as prominent as faces, but one of the properties I'm using there for my demonstrations is the so-called display property. And this property is special because Emacs uses it to tell a display engine to do something different than usual, like, for example, displaying an image. And yeah, that's basically it. I manipulate a buffer, tell it to display an image, and later I delete that part of the buffer and replace it again. And if you do this often enough, you can, for example, get an animation or a game going.
Okay, let's see one of those animations then.
Okay, I guess I'd grab for this the XBM demo.
Sure. Nice. You said actually that you can get this going pretty fast. I think you mentioned 60 frames a second.
Yes, this was for a different demonstration, actually.
Yeah.
This one doesn't really do this yet. So,
cool.
Yeah, this would be just the classic glider, and yeah, everyone should know this actually, but it's a pretty nice demonstration to make. It doesn't really take much time. In fact, I did this because at the place I work at, everyone had, almost everyone had to do this in the interview to demonstrate that they can program, and they could do it in any language they wanted. So I thought I'd do it as well, but this time in Emacs, and yeah, that's my result. Because there's already an Emacs actually, an ASCII one, but it's not as interesting and more useful as a screen saver.
Did your interviewer get how crazy and awesome that is?
Yeah, it helps out finding the candidates that can actually write code, and that's pretty important if you're going to be a programmer somewhere. But
Yeah,
not all places do this.
that's very
Some
cool. And all you're doing there is you're changing the display attribute for like what, a single character, or
no, this is single image there.
I
So
see.
yeah, so in Emacs you would take a string like a space, you would add a text property to it, the display property with the
Mhm.
image data,
I
and
see.
then insert it into the buffer. And then later you erase the buffer and do this again. And this happens at a constant interval, which I can increase and decrease here.
Would you mind showing us a little bit of that code and kind of how,
Oh, sure.
whether it looks really, really complex or it's actually surprisingly simple?
It's not that hard. If I, for example, scroll, okay, this would, of course, be the predefined patterns, which aren't that interesting. Yeah, this, for example, would be the image rendering function.
All right, let's increase the font size a little bit to make it easier to see. Okay, so you
Yeah.
have a vector with the images with the bitmap in it, and you basically just set that. I'll let you explain it. How's that?
Okay. So this function takes a vector. That was already correct. So it has to calculate the size. And yeah, we are iterating over the vector because for the data type we are using, an XBM image, we need a so-called bool vector, which is just lots of bits which you can manipulate directly. So yeah, we create one to alter, and yeah, we go over the oh, we do here an upscaling trick actually, as I can see. I don't know. Do you know
Yeah,
the pixel game style upscaling where you get a
yeah,
really jagged look? That's
yeah, yeah.
basically what I'm doing here, and I'm iterating over two vectors at once for this. Once over the original and once over the one we want to put the bits in. So we just do an integer division, and therefore figure out that in an area we can put all the same bits into it. Into another area, another value for the bits, and therefore we get an upscaled look, which looks very retro-like. Unfortunately, I unfortunately can't demonstrate it here because a second. For some reason, the increasing doesn't really seem to work.
That's okay. I'm sure you'll fix it some other time. But I can see how that bool vector you have, the vector of Boolean, so either true or false, translates into this monochrome image. But I know some of
Yes,
your other demos have colors in them. So how do you do that?
that's actually done with another image type. And
Mhm.
in the Tetris demo, I've used XPM. This is a textual image type. You can just create it in an Emacs buffer or directly manipulate a string. And I've went for the latter for reasons I will explain later. But a short version of it is that it supports colors, and that's why I've used it for the Tetris, because it needs colors, not more than 256, but a certain amount of them. And yeah, I did want to test out how suitable the image type is for actually doing anything in it.
So there's XPM and XPM you mentioned, and SVG. I think you've also mentioned that as
Yes,
you
yes,
can do.
that would be the most flexible type. It's used in browsers all over the place because people have found out these are very convenient to create, and
Mhm.
they are text too, but more like XML. So you'd
Mhm.
need an XML generating library, which do exist for Emacs Lisp, and yeah, you transform a tree into XML, and that can be done very easily because you can just tell it to take a part and replace it with another one by backquoting and unquoting. Could
Okay.
show this too. Second. So yeah, this would be the main function doing this. I temporarily define some values like the field width, height, actual width and height. I temporarily find here a function for transforming a number to a string because always typing numbered string was getting too much work for me. And yeah, this is just a backported tree where almost everything is kept as is, like An SVG starts with an SVG declaration and some attributes. And here I'm replacing the width attribute with the actual calculated width. And the same for the height. And later I use the same trick to where I want original background, default background, loop to all I need. I actually say game over or game one.
Yeah, I see. And I really like that.
That works pretty well for things.
Yeah, I really like the fact that you're using SXML, which I guess takes S expressions and turns them into XML without all that extra cruft that you would get if you had to just concat the strings or whatever. That's awesome. I've never actually used that. That's great. Okay, so you've got different ways of generating the actual image data. And can we take a step back to the XPN that you had before and show us just how you're setting the display attribute, which I know is super straightforward, or at least I think it is, but I want people to see how straightforward and non-intimidating it actually is. I'm hoping it isn't.
You want to see the actual image?
The part where you set attribute. So you know how you mentioned that this is this is just an attribute on.
Okay, put me the redrawing.
I'm getting slightly choppy audio also. Hang on a second. Let me adjust my bandwidth settings over here. Okay. Oops. Too far. Hang on a sec. Okay, is the audio slightly better now?
Yes, say for actually is no low.
Yeah, okay. Let me think. I will, let's see. I will turn my camera off. And I think I've lost your screen sharing. Sorry. Would you mind stopping and starting your screen sharing again? Okay, so I'm having problems on my side. I think is what's going on. So we will wait for the maybe network to clear up for a couple of minutes. And in the meantime, maybe you can tell me how difficult was it to start learning more about how to do graphics in Emacs? Were there some resources that you found very helpful, or maybe a sample code that you really liked?
In just search code that was this. This is the first time that you did assume this was all original. There are actually a few other demonstrations I've seen before. Like, for example, there's this Russian guy who did the SVG mode lines. And he was a great inspiration for me because he has a project where he is, for example, demonstrating SVG drawing, like in a very, very simple vector application. Another one where he's just demonstrating what is possible with a display engine. And yeah, I did look a bit at how he did all this, and then later found a more fully featured demonstration of something like Blobby Volley. I don't know if you have actually played it, but it was very popular in my class, so I did immediately recognize it again. And yeah, so I did look at how it worked. I did compare with SVG Clock, which is actually a package in GNU Alpa.
Yeah.
Which you can check out. I try. It had this bug with selection, but otherwise it should work fine. And from there, I did learn that it wasn't really much to do. You had a step where you did generate the image data, and another one where you did erase the buffer, insert propertize data, and yeah, wait a bit. And that's basically everything behind this. Sometimes you have to be very careful with speed, for example. You can't do anything that takes too much time, especially if you are regularly updating. Otherwise, Emacs can lock up. But once you've got around this, it's mostly smooth sailing, as they say.
Okay, so now that screen sharing is back on for me, I can see how short that code is. Really, just as you said, it erases the buffer, it inserts some text with an image, a display property, and point entered, I guess, so people don't accidentally end up in the middle of it. and it's
Yeah.
enough. Awesome.
Yeah, that's actually slightly bit different. The thing is that if you do these things, then point moves. So if you, for example, manage to click between the end and the image, you get a region which you can't easily deactivate, especially if it's updated very often. And so I'm using deactivate mark here and make sure the point always moves away before display even has a chance to show it. So this makes it look more like a game. I think the next thing I'll try out is how to actually hide the cursor so that you don't even get the idea to click there. And then I hope all my votes should be done there.
That's awesome.
So yeah, maybe resizing, that could be difficult. I mean, in games, it's very common that you have preset modes and full screen. And that's all you get, no flexible scaling or anything like this, though it seems to get better. So yeah, implementing that would be a good exercise, I guess.
So you presented this at the FOSS conference or something like that?
Yeah, Frostcon. It's a free and open source software conference in Bonn. And yeah, people meet up there to show all kinds of things. And I did want to give a talk for the Lisp room. So yeah, I did this time and had that as topic because I've invested most of my time in it.
And were they similarly amazed and not able to think of like more questions to ask you, or were there a couple of good questions that came out of that?
No, I did have a few questions after it, but they weren't really related to the talk. I did, for example, have someone who had showed me a rather puzzling problem with his input configuration. And someone else who asked me about the state of Emacs development, but that was pretty much it.
Okay.
And, okay, and some new followers, but that doesn't really count.
Followers always count, I guess. But I suppose not a lot of people have gotten a chance to play around with graphics in Emacs yet. But knowing that it's actually pretty straightforward, as you've shown, might get a lot more people into it. So aside from... go ahead.
Yes, it would be pretty cool because everything else are the built-in games, which sort of do that, but do it in a different way. If you, for example, look at the MetaX Tetris, which was the original I've tweaked, it is doing it slightly differently. If you're in text mode, it's using propertized text, which is colored. But if you're in graphical mode, it takes bits of text and adds a tile graphic to it. So they don't manipulate a single image, but many small images, which make up the whole grid. So this can work for simple puzzle games, but for anything more advanced, like something with sprites, that is objects that can move around freely in the game, this approach won't work anymore. So I did try this out to see whether I could surpass it. And it's possible, but sort of difficult too. So yeah, this is the easy part of it.
So the Tetris demo that you showed yesterday, and if you want, you can briefly show now, that's actually a single image as well, right?
Yes.
Interesting. That means that if you have any, say, breakout type things where you've got balls going on the diagonal, or Pong, I guess, would also be one of those things. It's hard to represent if you're just doing text. Well, actually, Pong makes sense in text, but you can do it more smoothly if it's single image. Cool. Okay. So let's see. So you. Oh, that would be great. Looking at the way it's actually implemented.
Yeah, or just basic demonstration of it. Yeah, can this be displayed? Because last time I did, I had like a 3-minute pause until it was okay.
No, it's playing perfectly.
Yeah. So this is the basic game. You can move a piece around, you can rotate it. Okay, I can't really display that with a square block, but with this one, for example, can rotate it both ways. And I have soft drop. And yeah, no hard drop yet, and no line clearing, and most of the other mechanics of the game, like no score subtract or anything. And currently I'm not using any advanced animation, but I could. And I guess I'll show how this part of the game was implemented.
Yes,
so,
please.
Yeah. So I did run into a bunch of problems with this thing because I did have to manipulate a lot more data than with the SVG game, where I only had to see whether a block can be moved or not, because there you have things like rotation and translation. So I had to work with vectors a lot, and I've discovered that in Emacs you don't really have much utilities for working with vectors, especially not if you want it to be fast. So I did reinvent lots of common functions and have accumulated enough to do a special utility library. I'm sure you have heard of dash.el.
Yes.
So this one would be v.el. And yeah.
Well, from yesterday's talk on seek.el, it does sound like vectors are underappreciated. So I'm glad that you're getting quite a bit more performance with them, even if you had to write all of your own functions. And
yeah,
I think you also mentioned you've been teaching yourself all of this stuff, the math for it.
Yeah. It wasn't much math actually, but I had to teach myself how you would re-implement these very, very basic things, like how would you create an empty vector grid with elements that are independent from each other? Because in Tetris, you'd have a two-dimensional grid, and you'd probably use the make vector function, where the initial piece would be just a normal vector. But if you do this, you will notice that these vectors are all shared, because Emacs doesn't store these as vectors, but as pointers internally. So I had to figure out how you could create a grid that was really independent. And this function, vgrid, this is actually what you would need to do. You could probably write it to be a bit more efficient, but it didn't make any practical difference here. So I would actually have a list, put in it a vector, which is independent, and then turn this list into a new vector. And doing this every time would need such a vector would have been really, really bothersome. So yeah, I did implement a function for it. And a few more, like nested access and modification of vectors. For this, studying dash.el was very, very useful, because my macrology is still improvable, I guess, but it does work. I'm not sure whether it's really, really useful there, but yeah, this is basically like the threading macros, which look like pointy arrows in dash.el, but used on vectors.
Nice.
So yeah, the implementation works basically like this. You would expand to recursive versions of the macro, and in the end have what you'd need, because this is a nested access to a vector. So yeah, I did learn a few other things, like there are not straightforward names for copying a vector. If you want to do a deep copy of a vector, you need to copy a tree, actually, as it turns out. And you don't need to just copy a tree. You need to use an optional attribute to tell it to copy vectors too. So yeah, figuring out these kind of things, it took way too much time. And yeah, I would have preferred that these were in a proper library like this one. So yeah, the last thing I've implemented was basic iteration, like do it like macro, but for vectors. And yeah, I guess I will have to do a few more. There are a bunch of libraries where I could steal from, like Scheme has. Scheme has a few very nice vector libraries. Clojure has too. Common Lisp has, but we already have an implementation of it, and it's not very efficient, because it's just does it on a list and then turns it back to a vector. And I would really like to avoid this for something like a game. So yeah, that was one of the stumbling blocks. I just did have to rewrite these and yeah, see what data structures can be used without too much pain, because this is really the reason why you use lists all over the place. It's just very convenient to do.
Did you ever
whether it's an A list or P list or anything.
Yeah. Did you ever get a sense of the performance difference? If you had implemented this with lists, maybe, or compared to vectors? Was your first implementation with lists, or did you jump straight to vectors?
I did actually jump straight to vectors, because it makes much more sense to keep it in there. So I didn't test this. I did only test my redrawing algorithms and ways I am actually manipulating the data. And yeah, there I did run into a few things, like yeah. I did describe the initial algorithm for doing something like a game, just recreating a whole image and inserting it again. And for this thing, I found out that this isn't actually fast enough. So I had to figure out a trick to actually make this work. But yeah, first of all, image is done here a bit differently. And as I've said, an XPM is a string, basically. So I thought that instead of creating strings all over the place, I could just reuse one and then abuse the fact that strings in Emacs Lisp are mutable. So I'm actually doing something like an array access on this string and manipulating a bit in this. Because an XPM image pretty much looks like you'd have a header and then just a list of ASCII art-like stuff. And if you manipulate this, you actually can shuffle pixels around in it. So I'm doing this all the time. It's not very pretty, but it works fast enough. So I'm doing this.
Wow. Okay, so let me see if I understand this correctly. So for performance reasons, you've really dug into how Emacs represents things internally, what's mutable, what isn't, and in this case, strings are working well for you. And I noticed that in your tile definitions, you're using you basically define your pattern as characters using the question mark syntax.
Yes, right. We have basically 4 types of tiles. Like this tile called X is just an empty tile where everything is a dot. And there are a few others that basically, the first 2 look the same, just with 2 different colors. Like A would be a light one, B would be a dark one, and C would be one with a ring around something bright. So yes, I'm turning these into images. For this, I'm using an algorithm similar to in the XBM live demonstration, where I'm iterating over these and then upscaling with an integer diversion. So yes, there's nothing interesting to be seen there. So once I've had that going and could actually put tiles on the board, I did test how fast it would be to just redraw the board every time, and it wasn't fast enough. So I did this on it. Yes, it wasn't fast enough. So I did this on a timer, and first I thought 30 FPS, which would be half of the original game speed, would be enough. But it wasn't. It just locked up Emacs for me, and I had to kill it and start over again. And I found out that it is 10 FPS if it's not byte compiled, and if it's byte compiled, 20 FPS, and both aren't fast enough in any case. So I had to find something better than this, and I thought, actually, I don't need to redraw everything. I could do it like in the original Tetris game that's shipped with Emacs and just do the redrawing manually. But that would have been not very elegant, I'd just say. And I wanted something more automatic that's still efficient. So I did think about this, and then I remembered that there is a library in the JavaScript world known as React. Maybe you've heard of it. It's been made by Facebook. And they've created this thing to solve the problem that doing manipulation of their JavaScript apps, the front-end code, wasn't just fast enough, and it was sort of bothersome to just modify their DOM. This is basically a tree representing all the HTML elements in a website. And they had an idea to don't do these updates directly to the DOM, but do this to a virtual DOM. So they have this virtual tree, and so they have a bit more abstraction in it with components and all that stuff. And sometimes it's time to change the way these are displayed. So they look at this virtual DOM, they compare it with the real DOM, and they figure out the differences and then just repaint these. And this is a very, very cool idea. So I thought, why not redo this here? Of course, in a more basic way, because game, but this is what I've settled up for doing. And wait a minute, this would be just a drawing function. Or there it is actually. Yes, I've done this with 2 functions only. Doesn't quite fit on one screen, but anyways. Yeah, I have an old board state, which is just a deep copy of the previous one, and these are 2 nested arrays. So I have introduced a flag, a so-called dirty flag, and this kind of thing is very common in graphics programming, that you have something telling that a redraw must be done. So every time this happens, I set this flag to a truthy value. So if this flag is set, I take these two snapshots and I compare them, then find out the differences and push these to a list with the character, with the tile that would need to be drawn instead. And this is later used in the actual redrawing function. So it checks the dirty flag, figures out these differences, and then if oh, this is actually a bit more complex than than I'm explaining currently, but it would just take a look at every difference and repaint it only, then create a new snapshot, and then do the insertion thing. And yeah, I've tried this, and this has been fast enough for 60 FPS. So yeah, downside with this is, of course, that it isn't perfect. If I would do full screen draws, like when I'm doing a title screen or switching to a randomized screen or anything like this, where I need to change almost everything, and if do this often, it would be slow. But I don't do these often, so it's okay in this case, and I guess the retro games would do the same. Things that would change a lot on the screen happen less often, and things that change a little happen more often. So yes, this does work out pretty well. The only annoying thing is that I have to set this flag often, like for every command that would manipulate the display. But that's fine with me. So yeah, I've added a few more things, like skipping 2 rows, because in the original Tetris, you actually have not a 10 times 20 grid, but a 10 times 22 grid. So you have 2 rows at the top, which are obstructed. Yes. And if you rotate a piece very critically at the beginning, you don't see part of it. And this is because the other part is drawn over it, but I don't have that at the moment, so I'm just skipping these 2 rows. And yeah, that's why it's a bit more complex than it should be.
Okay,
and,
so
yeah.
So for performance reasons, instead of updating the entire XPM data, you're just updating the regions that have changed, and you're doing basically a diff in order to figure out which parts to do that. I guess the advantage also of how you've implemented it is that if you decide to implement a different grid-based game, you can easily reuse the function versus creating something that's specific for Tetris that takes advantage of the fact that all the changes are going to happen in a known region. So it makes sense to do it that way.
Yeah, though I don't think I'll be doing any framework or game engine or anything like this, because it doesn't really feel reusable to me. And this has been the case for these retro games I've actually looked at. Most of these were hand-coded in assembly and not made to be reused again, which sort of makes sense for the hardware they're running on. But maybe you could do this. There has actually been an effort at doing such a thing by DTO, David O'Toole. You've probably heard of him because he has done a lot of things with Org mode. And yeah, he also has interest in this game aspect of Emacs and has released a prototype of a game engine called RLX. It lives on in a gist somewhere on GitHub. And yeah, it's unfinished, and later he did redo this, but in Common Lisp. So he put Emacs into a Common Lisp program because that felt easier to him, I guess. And I can't blame him really for this. But it's interesting that at least someone tried to do this.
Yeah.
So yeah, I probably won't be the one to retry it. Maybe I will if I figure out how to use SVG better, because it could solve a few limitations I have with my approach, but not for now.
Yeah, well, I'm looking forward to that too. It's one of those things that's always fascinating to demonstrate to other people as a way of showing them that Emacs can actually do a heck of a lot. Certainly, if you come up with a graphical way to do artist mode, then I'm like, okay, here we go. Let's try drawing in Emacs instead.
Yeah, that is one of the maybe things on my to-do list, doing something more advanced, like an actual drawing environment, or let's just say something for authoring images. Like I have this tendency to put animated GIFs on my projects. Not all of them, a few of them only, but I have used Photoshop for years. I have used GIMP for less, but I dislike both of them for creating GIFs because it just doesn't feel natural at all and more like bolted on, even with the gap plugin of GIMP. Yeah. And I figured that considering I have command line tools, I usually use to split and join these files, I could probably use Emacs for the preview part and add a few key bindings and then have a better environment than both of them combined. And, yeah, that would be pretty cool to have, but I'm not going to do this anytime soon. Maybe later if I'm done with this game.
I vaguely remember that you can actually watch animated GIFs inside Emacs. So
Yes,
and
yes.
then you can even step forward and backwards through frames, which is more control than I normally have with other applications. So that'll be interesting to
Yeah, I
see.
would intend to use these. These weren't available at the time I did my first graphical demonstration. I did actually use split frames and flipped through these with the same technique. And that was fast enough to display Keyboard Cat, this video you surely know, but not fast enough for anything of higher resolution or higher speed.
Uh,
So it would probably work for GIFs that aren't too large.
okay, here we go. Emacs is a high resolution, high frame rate animation engine. We'll see how it goes.
Well, to be honest, I'm pretty surprised that the display engine can actually deal with this without going too crazy or like flickering or anything like this. Maybe it's
Mhm.
because the image doesn't ever change its size or isn't displayed in another place, but always in the same place at the beginning of the buffer. I don't know,
Yeah.
honestly. I haven't really taken a look at it because it's very, very complex code. I assume it's using similar tricks like the ones I've used here, but of course on a much greater scale. And yeah,
Well,
maybe I'll learn to understand it later.
I look forward to your continuing experiments. I saw you were picking up some tips from demo scene programming for interesting graphical effects. So we'll see where that
Yes,
goes.
yes. Someone did actually ask me why not do a demo in Emacs, and I said, okay, maybe if it could skip the audio part because that is a lot harder to do than the graphics part, and maybe if we don't do bitmap because this is just too slow to manipulate at a 60 FPS full screen. And yeah, maybe the SVG type will solve this because you just generate text. You don't actually have to manipulate anything, like all individual pixels. And it already has a few tricks up its sleeve, like you can define a group of objects and then tell SVG to just repeat it or transform it or anything like this. And that should already
Mhm.
solve a bunch of headaches with it. I'm not sure how well it would be suited for something like a shooter or anything 3D, because it would have to be pseudo 3D, but maybe it could work out. Maybe. Um, there's this Wikipedia page about the very first shooter, and it looks very basic. Maybe this could be implemented in Emacs. It's just black and white with a few lines, and you are in a maze and shooting at things that look like floating eyeballs and that kind of stuff. It's pretty crazy. I can't
Well,
remember its name currently, but you'll sure find it out there. Maybe I can add later to
yeah.
this hangout.
That'll certainly be a more impressive demonstration than animate string or animate birthday presents. I look forward to seeing that come out.
Yeah, it would be pretty cool. Though I do remember that there's a Japanese guy. Probably I'm not sure whether it's the same one that did this calendar plugin, but he did some ASCII art labyrinth thing. So
Hmm.
maybe I could steal the math part from this.
Yeah, yeah. There was a class even, I think, in animation in Emacs. I'll go dig up the
Yes,
URL and
yes,
post
that
that
too.
too. Yeah. Okay, so you mentioned being impressed by the display engine in Emacs. Are there other interesting things you've come across, whether or not they're related to graphics? You know, things that made you go, "Hey, I didn't know Emacs could do that," or other things that you've incorporated into your workflow.
Yeah, for this one, I actually had to figure out how to use timers because it is one thing to just react to input, like it's a matter of just binding a command you've written to a key. That is very simple to do, and everything I had implemented in the live demonstration, the 2048 demonstration. But for the Tetris thing, I had to work with timers. You can basically tell Emacs to do things in either at a set interval periodically, or if it has idled enough time, like saving your buffers every 300 seconds. And
Mm-hmm.
yeah, so timers are pretty cool actually. You can do something like implement pseudo asynchronous processing with them. I do even know a package that does this, which is very unpretty, but it works if you want to defer actions. And yeah, but I've run into a few problems with timers. Like if you have more than a few timers with a very high resolution, or rather with a very little interval, it can lead to display bugs like your cursor flickering. I don't know if you've ever seen this, but this has annoyed me enough, and I've tracked down packages doing this and have replaced them with other packages, or even written my own in some cases. And yeah, so I did have to figure out how I would use a single timer and schedule animations and other things like that into Tetris. And that took me a bit of time to figure out, and I have been inspired by another retro game trick for this.
Yeah.
This is defined a bit over this. We have time in an amount of ticks. So every time a frame is rendered, this counter is incremented by 1. So this will eventually go into the negative values.
Right.
But it doesn't really matter here because we're doing this a bit differently. I have a list of scheduled events here, and each of these is a vector containing a few informations, like what interval this event has to be run at, what the condition is to run it at, and what function should be run. So I'm repeatedly checking these events, and then return a list of events that have to be run, and use this for the game scheduler. So what's basically happening here is that if we, for example, have told this that every time 50 frames have passed and the remainder of dividing the amount of ticks by 50 has to be 0, we would run a function moving the piece down in this game. So we could combine this with a few more, like for enabling animations. So I could add another event, like for example, if the piece has completely arrived at the bottom, I would add one function that would check whether lines have to be removed, and then make this flash these lines. So that would be a way to have animation in there. And this is basically a slightly smarter implementation of timers, which does not rely on running many of these concurrently. And yeah, I've basically reinvented that in a slightly better way for this. And this is one of the things I've actually learned from here, because later I've checked out this and found out that it's not too different from what I've done. It's actually also keeping a list of these things with vectors in them, but it's running them slightly differently. So yeah.
So let me get this straight. For Tetris, you're actually keeping your own scheduler instead of running different timers to update things. Okay. What's it? Do you remember off the top of your head what the granularity of an Emacs timer is? Can it deal with microseconds, or is it seconds, or?
Oh, you can actually go to milliseconds intervals. Everything below this will probably lock it up completely.
Yeah.
So I've, for example, seen amounts like 10 milliseconds or even 1 for some code, but nothing low. So yeah, if you're doing these, make sure you're not doing too much in this function. Otherwise, you can just lock everything up. And if you do something like entering the debugger for this function you are debugging and press Q to quit it, it isn't run anymore after this. And yeah, this is kind of weird compared to a real traditional game development environment, like something like Common Lisp or Scheme, where you actually get a helpful debugger that doesn't halt your complete game after this. But yeah, it's part of Emacs, I guess.
Well, it'd be interesting to see the kinds of debugging tips and tricks you can write about when you write a blog post about the different things you've learned doing this. Wow, very cool. Okay, so I noticed also you use a couple of little things to make your development easier, like the rainbow parentheses to show different colors for different nesting levels. Are there other things that you use to make your Emacs Lisp development easier?
Well, as I've mentioned before, I have started off with Vim, so I was very used to its key bindings and have went for evil. I'm using this for navigation, editing, everything like this. So yeah, it's very very basic Vim editing. The upside is, of course, that I don't really have to think about it, which is great for me. But I don't have any of these tricks like mutable cursors or smart parents or pirated up my sleeve. So it looks a bit more boring than other people editing. So yeah, my customizations are more about the workflow. Like I'm using Helm very extensively, like for switching buffers or checking out what timers have run out of control or other things like these. And yeah, I'm currently hacking on a replacement for it, which is a bit more lightweight and doesn't have that much bug potential because it's less lines of code. But yeah, these are what I'm mostly using. On this, I have set up Hydra for putting things on the F keys. So I have organized my key bindings by putting these on clusters of F keys. Like F1 is for all the help things, or F2 would be for customization and package-related stuff, and so on. And yeah, this has been a great productivity improvement for me. Yeah, sometimes I write small functions like something for displaying the info manual or resuming a Helm session or stuff like this, but it's mostly standard. So yeah, what else is there? I'm using Smart Mode Line, which is a cleaned up version of the original mode line in colors. It's less fancy than a power line, for example, but it's basic enough for me and helpful. So I've gone with this instead of obsessing over the right style for the delimiters for power line. Maybe I'll write my own mode line, because there's this SVG mode line, but it's too much bells and whistles for me. I'd rather use SVG to overcome the problems of the original mode line, like it being very, very limited in terms of font fallback, for example, or that it's just one line. Like if you would have a 2-line high mode line, you could, for example, put something else into it than just the current information. Like, for example, your current system statistics or something like this. Or maybe permanent messages, or I don't know. It would, of course, yeah, allow a lot of research what could else put there, because abusing the header line is, I don't know, a bit unreliable for this.
Yeah. I can see how you might use a display property to have like even just really tiny text or other status images on your mode line. So we'll see where that goes. Do you share your Emacs config anywhere?
Yes, I have it on GitHub. I have a bunch of things there because I'm not only developing fun stuff that is not really useful for others, but rather cool to look at. Like I have developed 2 packages for window management. Like yeah, one of these would be eyebrows, which I use for managing window configurations. Like if I would first and the second, it's much more convenient than using registers, because it does remember to save and load these for you. I have another one for dealing with popped up buffers, Shackle, and other than that, a few other small packages, like one for running things on saving, known as Firestarter. And I've ported a theme and done a bunch more.
Yeah, Firestarter. I came across that before. It's it looks like a really interesting way to make things happen when you save. So that's good stuff.
Well, yes, I did just wonder why nobody has really implemented this properly yet. I've bothered compiling a list of all the alternatives and how they how they aren't as powerful as mine, and yeah, so this one works for me pretty well, and I find it cool that other people think the same way.
Cool. Okay, so in terms of packages you'd recommend or that you really like using, you've mentioned Helm, and you've developed quite a few packages as well that that other people can check out. Are there other key recommendations you would like to encourage people to go and check out?
Yeah, of course, Magit, for example. I mean, Magit. Because it's just simply the best Emacs user interface I've ever seen.
It is very, very helpful.
Yes, even with a 2.1 rewrite, which did change a few things, like it did introduce a few more helpful hints, like this selection thing, which I had actually reported a few bugs for. Yeah, like it's drawing two thin lines around what you've selected to make clear that you're only committing this part. And yeah, but it has changed a lot. Like other key bindings that used to work don't work the same way as before. Like if I check out a new branch, I can end up with a detached head instead of just creating it, which is sort of weird, and a few others. But overall, it's been very, very much worth it for me.
Cool.
So yes, as of other packages, well, awkward, of course. You can just use it the way you need it. Like I use it very minimally, just for presentations and documentation and stuff. But I have seen a lot of setups from other people who have made a lot more with it. And this is pretty amazing, especially if you consider how complicated its implementation is, or just extending it, that people still can make really, really much with it.
Yeah, it's very complex internally, but when you're using it, the key bindings are very consistent, and the behaviors, it becomes a little easier for people to deal with.
Yes, that's pretty great. Maybe it's the second best interface I've seen in Emacs. Don't know, but
Well,
yeah.
I'm definitely looking forward to giving your literate configuration a good read. I saw some interesting snippets in there. Like you actually, do you still use typing of Emacs often?
Oh no, I did just set up its config file to be somewhere else. I did
Yeah.
use it when I wasn't really good at touch typing to improve this, but I don't know, maybe there's something better than just typing one-shot words for this.
Yeah. Well, maybe or maybe you'll play around with adding graphics to it or something else.
Maybe, who
That's
knows?
super cool. Okay, so your GitHub, by the way, it's also at Wasamasa, so I'll add the link to that, and people can go explore. But it's great to
Yeah,
see all the different things that you've put in there, and of course the graphics demonstrations and the walkthrough through the code. Thank you for that.
yeah.
You,
So
before we wrap up, do you have any other tips for people who are maybe getting started or trying to move beyond being just a beginner at Emacs? What helped you do that, 1 year, 2 year, 3 year transition?
well, I don't really have any tips for this because Emacs is, after all, very, very large. So for me, it was more of a thing like don't try to understand it all at once. You don't customize too much at first because you can get stuck there forever. And yeah, tackle it one piece at one time. Like if you want to know how to have a prettier theme and a prettier look, concentrate on this first before you get hung up with fixing bugs in it or in packages you're using, because otherwise you're not going to get anywhere with this. And yeah, because of my tendency to get stuck in other things, I've actually started a blog about it. I guess you've heard it. It's emexhorrors.com. It's a very different kind of blog compared to other Emacs blogs because I rant there about horrible things I find in its sources. And this happens to me rather often. Like at my job, I had to start a C# project. So first thing I did was installing C# mode. And when I booted it up for editing a C# file, I did just notice that it didn't initialize its mode properly because it wasn't initialized correctly in it. So the first thing I did was looking at its code, fixing it, do the pull request, and yeah, saying that off. And this happens to me very, very often. So I started a blog about this. I have a proper blog too, which is much more recent. So it just has one article yet. But anyhow, if you're interested in unusual topics about Emacs or just more advanced stuff, I'd recommend you to check these out.
So what was that URL again?
emexhorrors.com, and the other one was emexninja.com.
Emacs Heroes? Sorry.
Emacs Horrors.
Horrors.
Horrors, like in horror movies.
Oh, horrors. Okay,
Yes.
all right. emexhorrors.com, and the other one was Emacs
Ninja. yeah, that's what I've had there. I've read an interesting article where someone described ninjas as V users, SPI users, and Emacs users as pirates. And so I thought if I'm using evil, I must be an Emacs ninja. And that was the name for it.
All right. Okay. So that's where people can go find you on the internet. You're either on IRC as wasamasa or at emaxhorrors.com or emaxninja.com. Fantastic.
Yep.
Thank you so much for sharing. Folks, if you're listening and if you have further questions, you can drop by aforementioned Emacs Horrors or Emacs Ninja or IRC to follow up. But in the meantime, enjoy and keep having fun with Emacs, I guess. I'm going to stop the broadcast here now. YouTube will have the archive, and we'll see you around for the next Emacs chats or Emacs Hangouts.